Good morning, dear students. Today we are going to start with another topic of chapter Aldehydes, ketones and carboxylic acid. So, today we will see method of preparation of aldehydes and ketones. In the previous video, we have discussed about the three types of method of preparation. First, the methods by which we can prepare aldehydes and ketones both. This method we have discussed in the previous video. Now today we will discuss about the remaining two methods. One, that is method of preparation of aldehydes only, and second, method of preparation of ketones only. So let's see. Method of preparation of aldehydes only. In this method, there are 5 main methods by which we can synthesize aldehydes only, but not ketones. They are Rosenmund reduction, Stephan reduction, Itard reaction, Gattermann-Koch reaction or Gattermann-Koch synthesis, and Rimmer-Tiemann reaction. Out of these 5, last one, that is the Rimmer-Tiemann reaction, we have already discussed in the chapter alcohols, phenols and ethers. When we have discussed about the chemical properties of phenol, so the first reaction is Rosenmund reduction. In this, acid chlorides are easily reduced to the corresponding aldehydes by passing hydrogen gas through boiling xylene solution in presence of palladium catalyst supported over barium sulfate and partially poisoned by the addition of sulfur or quinoline. This reaction is called Rosenmund reduction. Limitation of the reaction is this reaction is not suitable for the preparation of formaldehyde because formyl chloride, that is HCOCl, it is unstable at room temperature, and this is the reason why Rosenmund reduction is not applicable for formation of formaldehyde. This reaction generally goes in very good yield. Next is Stephan's reduction. In Stephan's reduction, the reaction of stannous chloride with HCl give rise SnCl4. This is not SnCl2, this is SnCl4. So, with this reaction, formation of hydrogen takes place. When an ethereal solution of a nitrile is reduced with stannous chloride in presence of hydrogen chloride gas at room temperature, imine hydrochloride. This is imine hydrochloride is precipitated. This upon hydrolysis with boiling water gives aldehyde. For example, SnCl2 with HCl liberate nascent hydrogen. This nascent hydrogen gives rise imine hydrochloride which react with boiling water. So if you will add the water, you can see here water addition. So there is formation of RCHO. If water will be added, you can see here water will be added and formation of RCHO with the liberation of NH4Cl. You can directly write the reaction RCN. In first step SnCl2 oblique HCl. In second step boiling water. Directly you can write the formation of aldehyde. This is known as Stephan's reduction. Next is, in the Stephan reduction, aromatic compounds can also be synthesized. Benzonitrile, when it reacts with the Stephan reagent, that is reduction takes place with a nascent hydrogen liberated by SnCl2, then formation of benzyl dimmine hydrochloride. This is benzyl dimmine hydrochloride. Benzyl dimmine hydrochloride, this is the name of this compound, is obtained, which react with the water, boiling water, and give rise aldehyde with the liberation of ammonium chloride. Ammonium chloride will be obtained, or the release of ammonia react with HCl and form the ammonium chloride. Next reaction is Itard reaction. In case of Itard reaction, toluene can be oxidized to benzaldehyde with a solution of chromyl chloride, CrO2Cl2. This is the reagent, chromyl chloride. In presence of CS2, carbon disulfide, or CCl4. The brown chromium complex, thus precipitated, is separated and decomposed with dilute acid to give benzaldehyde. This is brown chromium complex. Same way, metaxylene on treatment with chromyl chloride followed by the hydrolysis gives the good yield of meta-methyl benzaldehyde or meta-tolualdehyde, and the reaction is known as Itard reaction. Next, and the fourth one is Gattermann-Koch reaction. When a mixture of carbon monoxide and HCl gas is passed through a solution of benzene or toluene in nitrobenzene at 323 Kelvin in presence of a catalyst like anhydrous AlCl3 or a small amount of CuCl, benzaldehyde or para-tolualdehyde is obtained. So in the Gattermann reaction, the starting reaction will be with the reaction of CO and HCl. It will give rise HCOCl. This is formyl chloride, which is unstable. So this formyl chloride react and there is release of H. Whatever hydrogen is here, this H and Cl will be removed as HCl, and this CHO group will come to form the aldehyde. So formation of benzaldehyde. Next reaction is Riemer-Tiemann reaction. This reaction you know very well from the alcohol chapter. In this treatment of phenol with the chloroform in presence of aqueous sodium or potassium hydroxide. This is the reagent. Followed by the hydrolysis of resulting product gives 2-hydroxy benzaldehyde, also known as salicylaldehyde. Instead of CHCl3, if you will take CCl4, then you will get the salicylic acid instead of salicylaldehyde. So you know this Riemer-Tiemann reaction, which is one of the very important reaction. Now, third one or the last, method of preparation of ketones only. These are the methods by which we can prepare the ketones but not aldehydes. So mainly 4 are there in your NCERT. We are going to discuss only these 4. Many others are there. First one from the acid chloride or acyl chloride. Acid chloride means RCOCl. When it reacts with the cadmium chloride, you will see the reaction in the next slide. Second is from the nitrile. Nitrile means cyano group. When cyano group react with the Grignard reagent, then you will get the ketones. And this reaction is known as the ascending of series. Ascending means number of carbon can be increased in this. Third is from the benzene by the Friedel-Crafts acylation. You know very well from the class 11, when benzene undergo Friedel-Crafts acylation, then there is a formation of aromatic ketone because benzene is there. And last one is not as such method of preparation, but it is a type of rearrangement in which the ketonic group gets rearranged at ortho and para position. So let's see. So the first reaction is from acid chlorides and acyl chlorides. In this, ketones can be easily prepared by the action of a suitable dialkyl cadmium on an acid chloride, and this dialkyl cadmium will be prepared by the reaction of cadmium chloride with the Grignard reagent. There is a formation of dialkyl cadmium. This dialkyl cadmium then react with the acyl chloride or acid chloride. So what will happen? Removal of CdCl2, 2 chlorine from the two molecules, and cadmium. Cadmium is having valency 2+. So formation of CdCl, and this R group will attach here. So there is a formation of ketone. Grignard reagent cannot be directly used in this reaction because Grignard reagents, being more reactive than dialkyl cadmium reagent, would react with the ketones formed in the reaction to give ultimately 3-degree alcohol. It means it is clear you cannot use this Grignard reagent here. Otherwise, instead of ketone, you will get the alcohol. So if you want to synthesize alcohol, then Grignard reagent you can use, that we have seen in the chapter alcohol, phenols and ethers. Second is from the nitriles by the reaction of Grignard reagent. Both aliphatic and aromatic ketones can be prepared by the action of suitable Grignard reagent on an alkyl or aryl nitrile, followed by acid hydrolysis of the intermediate addition product. For example, this is Grignard reagent and this is cyano. This R can be alkyl or aryl. So what will happen? In this the triple bond, one pi bond will break, and this formation of imine salt and react with Grignard reagent and form the bond. You can see the imine salt. Formation of imine salt will takes place. So this imine salt undergo hydrolysis, addition of water molecule. So due to this, there is a formation of RCOR, ketone, along with the release of ammonia, NH3, and a byproduct MgOH and X. So these two are the byproduct, and this product will be obtained. Now next is the Friedel-Crafts acylation. This is the very well-known reaction, and this is one of the most convenient and widely used method for the preparation of aromatic ketones, in which ketonic group is directly attached to at least one aromatic ring, and it involves the treatment of aromatic hydrocarbon with an acid halide in the presence of Lewis acid such as anhydrous AlCl3. So you can see here easily, here hydrogen is there. This hydrogen and chlorine will remove as HCl, and this carbon will attack here. So formation of COCH3 group will there. So this is the Friedel-Crafts acylation. Next is the Fries rearrangement. It is a type of rearrangement. Phenyl esters on heating with anhydrous AlCl3 in presence of CS2 as solvent undergo a rearrangement in which acyl group migrates from the phenolic oxygen atom to the ortho-para position of the benzene ring to give the mixture of ortho and para hydroxy ketone. So you can see here is the hydrogen, right? Here is the hydrogen, everywhere hydrogen. So this rearrangement takes place at the ortho and para position. At low temperature favors the formation of para isomer, whereas high temperature favors the formation of ortho isomer. So this hydrogen will migrate here and form the OH, and this group will come here. So ortho and para substituted product you will get in the Fries rearrangement. Now the physical properties of ketones and aldehydes. Because the polarity of carbonyl groups, aldehyde and ketones are the polar compounds. Dipole-dipole attraction, although important, and are not as strong as the interaction due to the hydrogen bonding. As a result, boiling point of the aldehydes and ketones are higher than those of the non-polar alkanes, but lower than the alcohols. It means boiling point of alcohols are more. Lower aldehydes and ketones are soluble, as in the lower aldehyde ketone, few hydrogen bondings can exist. So aldehydes C1, C2 are gases at room temperature, C3 to C4, C11 sorry. They are straight chain saturated aldehydes are liquid, and the higher are the solids. Presence of alkyl group tends to lower both boiling point and the melting point, as it does the presence of unsaturation, and lower molecular mass ketones are colorless liquid at the room temperature. Now the boiling point of the aldehyde and ketones are intermediate between those of alcohols and alkane, means higher than alkane but lower than alcohols. Aldehyde and ketones have higher boiling point than alkanes because of dipole-dipole attraction between the molecules. Carbonyl group polarity makes these dipole-dipole interaction possible. So these are the reasoning. Aldehydes and ketones have lower boiling points than the corresponding alcohols because no hydrogen bonding occurs at it does with the alcohol. So in case of alcohol, hydrogen bonding are there, so their boiling points are higher. Water molecules can hydrogen bonded with the aldehyde and ketones. This hydrogen bonding causes low molecular mass aldehydes and ketones to be water soluble. So few aldehyde and ketones are water soluble due to the presence of hydrogen bonding, which are lower one. Although low molecular mass aldehydes have pungent, penetrating, unpleasant odor, higher molecular mass aldehydes are more fragrant, especially benzaldehyde, which are there in almonds. Ketones generally have pleasant odor, and several are used in the perfumes and air fresheners. Now reactions of aldehydes and ketones. So we have to see the different reaction of aldehyde and ketone, in which first is nucleophilic addition reaction. Addition or elimination reaction means addition followed by the elimination. Then reduction of aldehyde ketone, oxidation of aldehyde ketones, and few reaction which involve the alpha hydrogen. These are the 5 main categories. But before going through the reactions or the chemical property, first we will compare the reactivity of aldehydes and ketones. When we see the mechanism of nucleophilic addition reaction, so in the nucleophilic addition reaction, here you can see it is the planar structure. Carbonyl group is planar, right? So nucleophile is attacking at the top side. So addition of nucleophile, and then it is treated with the water in acidic medium. So this H will combine here and form the alcohol. Clear? When we see the relative reactivity of aldehyde ketones, aldehydes are more reactive than the ketones. Now see how and why. Aliphatic aldehydes and ketones. When we talk about the aliphatic aldehydes and ketones, then in this First effect is the inductive effect, which are responsible for their reactivities. Reactivities of the carbonyl group toward the addition reaction depend on the magnitude of positive charge on the carbonyl carbon atom. Hence, any substituent that increases the positive charge on the carbon increases its reactivity towards the addition. Introduction of negative group increases the reactivity, while introduction of alkyl group plus I effect decreases the reactivity. So they are directly proportional to the plus I and minus I. Greater the number of alkyl group attached to the carbonyl, hence lower it's the reactivity. So you can compare here in first, second and third. This is first, this is second and this is third. So here more bulkier groups are there. Here one alkyl group is there and there no alkyl group is there. So higher the alkyl group, it shows the inductive effect as well as the steric hindrance. Here in 4 and 5 you can see more bulkier groups are there. So steric hindrance and inductive effect are responsible. Higher the bulkier group or more the number of carbon, then reactivity will be less. Second factor is the steric effect. As I told you, steric hindrance will be more, reactivity will be less. Aromatic aldehydes and ketones. In general, aromatic aldehydes and ketones are less reactive than the corresponding aliphatic aldehydes and ketones. It is due to the electron releasing resonance effect of benzene ring. You can see the delocalization in this benzene compounds. You know all these delocalization well. So because of the delocalization, aromatic aldehydes and ketones are more stable and less reactive. And the order of reactivity of aromatic aldehydes: phenylacetaldehyde, benzaldehyde, acetophenone, benzophenone. So in this way you can compare the reactivity. Now in chemical properties of aldehydes and ketones, we have discussed the nucleophilic addition, in which attack of nucleophile will be there. So after the attack of nucleophile, hydrolysis in acidic medium gave rise the phenol. And one important thing of the reaction, in this reaction carbon atom of the carbonyl group changes from sp2 to sp3 hybridization. So in next video we will see the reactions of aldehydes and ketones. We will discuss about all these reactions. Thank you. God bless you. Keep revising.